Hello, I'm happy that you decided this Sunday to be with me with Sigmoid. As you can see, you are with Sigmoid now. Hope you will like today's workshops. Will be more practice. We will learn much more, and maybe this practice will help you to understand all the theory very much better. So, as you can see, we have today restricting and sorting data. When I'm talking about restricting, it means that we will select the data which satisfies a specific condition. So let's see the content of the today's lessons. And as you can see, we have the where clause. Some of you actually use this clause in their homework, but we will talk much in detail today. And the next slide, actually, the character strings and the dates, worked by clause, select top clause. The SQL functions, we have two types of functions in SQL and in SQL. Okay, tell how you want. We have single row functions, which we'll talk today about them, and also we have let's say multiple row or group or aggregate functions. They have multiple names, multiple rows, multiple names. About them, we will talk at the next workshop. Next, we'll have the character functions, the numeric functions, and date functions. So let's start. The where clause is used to filter the records. You can restrict the rows that are returned from the query by using the where clause. It contains a condition. As you can see from the syntax, it contains a condition and it directly follows the from clause. If a condition is true, the row meeting the condition is returned. So in your homework, someone wrote like to change that email where the person ID is 4, or where the email address is null. So that was the condition, and it met the condition that is true, and it changed that email. Looking at the syntax, we have the where condition. Condition is composed of column names, constants, and a comparison operator. It specifies a combination of one or more expressions and Boolean operators, and returns a value of true or false. Let's look at an example. I will switch to my. So we will use the Sql database. Okay, so I will switch to English first. We will use the Sql, and let's write an example. Select all from. We will select from course, and let's put a condition where the credits are equal to 4. If we run this clause, we have the following. Actually, this select met the condition that the credits must be equal to 4, and it displayed as the result. We can combine 2 or more conditions using the logical operators and or, therefore allowing us to create as many combinations of conditions as we want. Let's go back to our management studio and let's write another example. For example, let's write a select all from course where the title we will use the like operator, which we talked about yesterday, and we'll write the following. So this pattern will display us the data which starts with a C, the title which starts with a C. And let's put another condition that the credits must be equal to 4. So here we have, I think it will be, okay, we will have practically the same output. Okay, much more example. So we have 2 conditions. As you know, where it allows you to choose, not to choose, but if we have, let's say, a row of conditions, we can, it's enough for only one to be true. So here we have calculus equal to 4. It's a C, it's a 4. It's not a C, but it's a 4. It's a C, but it's not a 4, and so on. I think you got the point. And instead of or, we can use and we will get less results, calculus and chemistry. So now I think we'll go back to our presentation, and let's see how character strings and dates can be processed in our database. So character strings and the data values are enclosed within quotient marks, as you can see here, some examples. Also, character strings are not case sensitive. As far as I remember, in Oracle database, characters are case sensitive. So we, for those who don't know, case sensitivity is when the lowercase and let's say strings are case sensitive when there is a difference between a lowercase and an uppercase. But in our Microsoft SQL Server, it's not so. Dates instead are format sensitive. This means that the dates respect a specific format. And there are some examples of date and time that and their format. Let's say date time, small date time. So we will go back and we will write some examples for a better understanding. So let's write select all from person first to remember how our table looks like. Execute. Let's take a look at the so the first name. Here we have some names. We have Roger, which is a name that it's not met only once. And now let's make a complex query with a where condition. And let's say that the first name will be equal to Roger. So if we run this query, we got the following examples. Okay, we have 4 Rogers. But if we write, for example, an O and G with uppercase, we will receive the same result, as it is not case sensitive. Instead, let's select. Now let's play with the data. So with the let's say with the columns with date time data type. Select all from person again. So if we write here, we look how our data looks like, and let's say we would like to select all from person where the enrollment date. Okay, enrollment date. It will be, for example, 1st of September. But we will write it in the following way. We'll write 2005, 0901. And when we'll run this query, we'll get the following result. Okay, not this one. We got the following result. Okay, but the same date can be written in different formats. We can write the same date as we are used to see this. We are used to see the day, the month, and the year. And if we run, actually, we got a mistake because, as I mentioned, dates in the Microsoft SQL Server are format sensitive, and we have to respect that format. So in the slides, I have included some examples of data and time format and their format. So now I have 2 questions for you. Let's go back to our database, to our table. So take a look. And how do you think the columns? hire date and enrollment date from the person. Which data type are they? It's a date time. In order to check it, we can do the following way: sp help, and we write the name of the table. We run it, and if we look here, we have date time. Yes, it was true. It was pretty intuitive having the slides and the table displayed. So if we are not sure, we can check with the sp help. So take a look at the date time. We have here the nanoseconds, and the small date time, it omits this nanoseconds. And now we have the second one. The next one will be order by, but before it, let's repeat some. Let's resume. Better to say, let's resume some knowledge of yesterday's workshop, and let's write some simple queries, like to repeat the operators. It will be select all from student grade, and let's say where the student ID, where student ID, it's different. And as you remember, we can use different in the different sign we can use. So the same can be done in this way. If we want to display a range, we have the between. For those who did their homework, they answered at the quiz. Let's do the following way. We select all from student grade, where we have a condition, for example, the grade to be grade to be between, let's say, 2.0 and 4.0. This will give us a range of marks from 2 to 4. With if we represent it mathematically, it will be the following way. It's inclusive range. Also, we have the in operator. It will be the following way: select all from student grade, where the course ID, let's say it's not in a specific tuple of values, for 1, and what else we have here, 461. And if we run this, we got the following. So it will display all the information from the student grade table, where the course ID is not equal to one of it. And I think that's pretty okay. But also I will remember you about select all from a student grade, for example, from student grade, where the grade is not null. Don't forget about it is not null, because it's a useful condition which you'll use for future studies. Because if we don't specify not null, we have some issues here, and we have some null values which can make some problems if we work future with data. So let's go next with the order by clause. The order of rows that are returned in a query is undefined. So we have a bit of messy order of data. But here comes the order by clause, which can be used to sort the rows. You can specify a column. Yes, we can specify a column. We can specify multiple columns here. And also you can specify the order, ascending or descending. I have to mention that ascending order is by default, Meanwhile, the descending order is you have to mention it. So rows with the same, when we have multiple columns, for example, you have the first order by first name and last name. Firstly, it will make sorting by the first name. And then if, for example, there are 3 persons with the same name, with the same, let's say, Anna, then it will look for the next column and it will sort by the next column. And so happening, it's happening when we have multiple columns. It looks for the first one, or if there are some equal values, it goes next. And if there are also some equal values, it goes next. Looking at the syntax, we see that we can specify the order, as I mentioned, ascending and descending. Let's look at some, also we can sort by an alias, by a column number, or by multiple columns. Interesting about the column number, but it is possible this too. So let's go here and back, and let's make some, if you have questions, please ask. I'm open to answer. I will try to answer to your questions from, let's say, student grade. And a nice way to see the results, it will be to order by grade, because it's a numeric. Yes, we can sort in the numeric and date, time, and the strings and everything we want. But as you can see, the first will be the null values. And then it starts with 1.5, 1.5, and moves so through to 4. Okay, but we want, for example, this is one way how we can sort. We can sort by one column. As you remember, in the table persons, we have multiple persons with the same name, Roger. So let's select all from persons first, and then we will make beautiful sorting. Here we have Roger. So let's select the first name, and then let's select the last name from person, and let's order it by first name, and then let's sort it by last name. So let's sort it, and as you can see, everything okay. We have Carson. Yes, we have here Carson. Let me make it much about here. Okay, I wanted to make it bigger. I hope you see. So we have Carson. We have not Rachel. We have Roger. Yes, and it first HI, HO, and then it goes further to the next letters. Also, we cannot specify the column. It automatically it will display only the column we want, but it will make the sort of by both conditions, by both columns. Here we have multiple columns. And also I said that we can sort, but before going to sorting by number, we can sort in different orders. Let's say we want to sort the first name in descending order, but the second one in ascending order. So we get, if we look at our Carson, it is quite at the end, and we have Roger first. It's a descending order, but here it's, as you can see, there is the ascending order. Now we can sort by an alias. So if we select, for example, first name and let's say again the last name, but the last name we will give an alias, will be let's say we would like to, doesn't matter, an alias with not so much importance here, but it has to have some importance. So from just you to know to understand how it works. So from person and order by ln, let's say. And if we run this query, it will be good. So it displays our ln and it sorts by this alias. So we can sort by alias. And another nice approach when you want to sort is to use a column index. But first of all, let's make a select, and to understand how we select all from person. So we have 1, 2, 3, 4, 5, 6. Let's say that we want to let's sort from discriminator to it will be much easier to understand. You will have first I, and then everything with S in an alphabetical order. So select all from person, order by 6. So if we run, we have I, and so, then we have student. So don't forget, we start the counting with 1, 2, 3, 4, 5, and 6. And another, okay, we haven't used the where clause. Let's mention here that the column index. And another way to, not way, but I will show another example. Let's write the following query, select last name, for example. Then let's, okay, last name. Then let's choose the first name. Then let's choose the hire date. From person, obviously, this table, it will be used today a lot. From person, and let's put a condition where hire date is not now. And then order by hire date. Okay, hire date, I made a mistake, hire date. So if we execute, we put a condition. That was just an example of quite fully quick. Now let's go back to our presentation. Yes, here I showed you, I think it was useful to you to see these examples. Select all from students. As I said, 1 column in ascending order, 1 column in descending order, 1 column which is not in the select list, 2 columns ascending and descending order in different orders, by an alias, by a column index, and we go to the next slide for the select top. The select top clause allows you to limit the number of rows or percentage. As you can see here, we have a percent of rows returned by a query. This clause is used on large tables with thousands of records. Turning a large number of records can be returning such a large number. It's quite complicated and it requires some performance. Because the order of rows stored in a table is unspecified, the select top statement is always used in combination with the order by. Therefore, the result set is limited to the first and numbers of the word. So here the expressions, in the expression we specify the number of rows we want to see. In the slide is shown that the syntax of the top clause with a select statement. Following the top keyword, it is an expression, as I said, that specifies the number of rows that will be returned. The expression is related to a float value when percent is used. Otherwise, it is converted to big int values. The percent keyword indicates that the query returns first and percentage of rows, where n is the result of the expression. With ties, here we have with ties in square brackets means that is not required, it's optional. The with ties allows you to return more rows with values that match the last row with in the limited result set. Note that with ties may cause more rows to be returned than you specify in the expression. Now let's look at some examples in order to understand much better all the information. Let's make a select top 10 from person. This star is used to mention the columns, but the top 10, the number of rows. So if we run, we get the top 10. Also, we can use percent. Let me type. So we top 30, for example, 30% from person. So if we run, we get the, as you remember, we have 34 records, and therefore 30% will be 17 records. We can specify a condition. We can specify, for example, a select top 5 first name from person. Okay, from person. And let's say that where the first name, for example, will be like 5 characters long. So if we run, we get the top 5. If we do not write top 5, we get the following result. Let's see. We have 12 results. But with ties, don't forget about with ties. I will write here again, and I will run these two queries at the same time in order you to understand. We will write top 5 with ties, and as you remember, with ties requires order by clause, and let's say we will order it by the first name in descending order. So let me run these two at the same time. Okay, here we have the top 5 first name and the top 5 with ties. So let's take a look. This is the first query. We have Gittes, Peggy, Roger, Laura, and Wayne. When we use with ties, we got the same value multiple times. Here, it will be much easier to you to understand. Here, let's make an order by first name in descending order, and let's run again this two. So we have Wayne, we have Stacy. Okay, but we have here the 5, but here we have 6. Why? We have the same value, more than only 5, only the top 5. So therefore, it will display all the values which are equal to the top number, let's say. I hope you got it. I tried to really explain you how it works, but I think you got it. Okay, now nice topic, let's say. Sql functions. It's a very powerful feature in SQL. You can use functions to do the following. You can use functions to perform calculation on data. You can modify individual data items. You can manipulate output for groups of rows. You can format dates and numbers for display. You can convert column data types. So SQL functions sometimes take arguments and always return a value, as you can see in this example. I have to mention that we have 2 types of SQL functions. We have single row functions and multiple row functions. Single row functions are those functions that operate on single row. on single rows only, and return one result per row. It returns one result per row. There are different types of single row functions. We will discuss about char functions, number functions, and date functions today at this workshop. And we have multiple row functions. And they are those functions that can manipulate groups of rows to give one result per row of a group of rows. These functions are also known as group functions, but about them you will learn at the next workshop. Let's study the single row functions. So single row functions act on each row that is returned in a query, and it returns one result per row. It can be possible to return a data value of a different type than the one that is referenced. Also, they accept one or more arguments. Arguments can be a column or an expression. In addition, they can be used in select, where, and order by clause, and can be nested. By nested, I mean it means that the function can be defined inside another function. But more about them we will learn at the next workshop. So now we will see some examples. Let's see here. We have character functions. About teaching part, I prepared a separated slide with an example. So let's see better. So we have ASCII returns the ASCII code value of the leftmost character of a character expression. So we have here select first name, ASCII the first name as codul primului caracter from person. Okay, for those who know the ASCII table very good, I think you got that K it's 74, G it's 71, and this and so on. So let's go next to the char. The char returns the single byte character with the specific integer code as defined by the character set and encoding of the default collation of the current database. So select char 65 will return as an A, an uppercase A. Char index searches for one character expression inside the second character expression, returning the starting position of the first expression is found. So searching for a G in Sigmoid, you can find it here, but also you can find it the index by starting counting with 1, 2, 3, and we got a 3. Concat returns a string resulting from the concatenation or joining of two or more string values in an end-to-end manner. So select concat facebook.com, and it returns a concatenated string. We have a concatenation with plus that we used, as you remember, we used it in aliases when we concatenated some multiple columns. Here we can we can do it so concat with space it with separator, so returns a string. Okay, I will not read all the definition, but concat with separator, you have to indicate the separator, and you have to then you have to indicate all the strings that you want to concatenate. And therefore we got www.facebook.com, and after the last one it doesn't put the separator. Data length, it returns the number of bytes used to represent any expressions. So Sigmoid has 1, 2, 3, 4, 5, 6, 7. It is on 7 bytes. Difference returns an integer value measuring the difference between the sound values of two different characters expressions. So if we got a 0, it's different. If we got a 4, it's similar. And if you read this strings, juice and juicy, it's quite similar. An interesting, to be honest, an interesting function. I don't know where to use it in our course, but for sure there are some applications, some nice applications with it. but I think you should know about it. It's a nice function. We have the left. It returns the left part of a character string with the specified number of characters. We have SQL tutorial and free. We select the first free, and it returns us SQL. We have the len. Len returns the number of characters of a specified string expression, excluding training spaces. So it excludes a space and and returns the length. Lower, we convert to lowercase and we got DEC. Left trim returns a character expression after it removes leading blanks. So data engineering camp, we got this string. And char returns the Unicode character with the specified integer code as defined by the Unicode standard. So also you have to know this all these codes if you want to display them. Path index returns the starting position of the first occurrence of this pattern in a specific expression, or 0 if the pattern is not found. So we have SQL here. Let's count 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11. So the first letter will be on 11th, let's say, byte, and we got the 11 position, let's say. This SQL will be met in the 11th position. We have the right. As the same with the left, if we have a string, we have the length, and we want to take, let's say, the 4 characters from the right, and we got camp. Right trim, the same as left trim, you remove all the trailing spaces, and we got a beautiful string. Space, it returns a string of repeated spaces. Here we have 5 spaces. Okay, it's impossible to see, but I checked. I really checked, and there are 5 spaces. str returns character data convert. Okay, I will read this definition, but in short, you have a number and it converts to okay, not a number, just in this example I used a number, and you convert it to a string. And here is a string, actually, not a number. Stuff inserts a string into another string. It deletes the specific length of characters in the first string at the start position, and then inserts the second string into the first string at the start position. So we have the data engineering show, but we don't have show here. We have only camp. So if we start to count 18, 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16, 17, 18. Okay, where is S? It's 18. From the 18, we remove 4 characters and we replace it with camp, and that's the result. Substring, pretty intuitive, the name, returns a part of the character binary text or image expression. So from the data engineering camp, we want to remove from the position 5, 12 characters. And actually not from the five position, but the next, like if we see here, we have 1, 2, 3, 4, 5, and we have from the 6 to 1, 2, 3, 4, 5, 6, 7, 8, 19. Oh, 19. Yes, I forgot to count. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12. And actually got some space here. Upper, pretty intuitive, it converts to an uppercase. Number functions. Okay, if you have some questions, please ask. I'm open to answer to them. We have a lot of number functions. As you can see, a lot of trigonometry. I don't know if it is so easy to work with trigonometry in our database, but let's see. We have absolute value. We have the arc cosine and radians. We have the arc sine in radians, and it returns. We have the arctangent in radians. And I let some examples you to understand how we work and what is displayed and how to write these functions. We have returns the angle in radians between the positive x-axis and the ray from the origin to the point x, where x and the values of the two specified float expressions. Quite complicated, to be honest. I don't know where it is used, but we have to know them. Like, it's not mandatory, but I think you should know at least of its existence, because when you will use it in future, maybe you will remember, oh, I remember a girl from Sigmoid told me about ATN2, and I can use it, like she told me about it. I don't know if this will happen, but I think you remember my lessons. We have the sailing. Sailing returns the smallest integer greater value. So we have 5.55. It gives you the sailing. The sailing, it's 6 in this case. We have the cosine in radians. We have the cotangent in radians. We have the degrees. Okay, I used an Romanian Alias because this should be, I don't know why I did it, but okay. From radians to degrees. If we have the exponential, returns the exponential value. For those who know, exponential value is it's 2.71. We have the floor. We had the sailing, we have now the floor, and the floor for 5.55 is 5. So remember, it takes the integer value. As in the sailing, we took 6, now we took 5. We take 5. We have the pi, in case you forgot how pi, the digits of pi, you can use it by a select pi function. We have the log. It returns the natural logarithm. And we have the base 10 logarithm. It's log 10. Maybe you remember from school that logarithm of base 10 of 100 is 2. In case you forgot, I remember. So power returns the value of a specified expression to the specified power. So we have 4 to power 2. We got 16. Next, radians returns the radians when a numeric expression in degrees is entered. So we have the number of degrees and we got the radians. We have the rand. The rand returns a pseudo-random float. Remember, float. A value from 0 to 1 exclusively. Actually, we won't get a 0 or a 1. And we have the round. The round returns a numeric value rounded to a specific length or precision. So we would like to round 23.415 to 2 digits, and we will get 23.42. And also we can play with these numbers and to round it with more precision or a fixed precision and so on. The sign returns a numeric value rounded to the specific length or precision. So now in this case, for the sign, we got -1. And also we have the sign. Returns the sign in radians. The square root, maybe you use this in programming languages, you know about square root. Returns the square root of a specified float value. We have square root of 169, it's 30. And we have the square, returns the square of a specified float value. And the square for 13, it's 169. Actually, it works. It's equal of these two values. And we have the last one from the numeric. I think, yes, it's the last one from the numeric. It's the tangent. And the tangent for 1.75 is the following number. And the last, let's say, functions for this workshop, it's the date functions. Pretty nice functions, to be honest. You can do a lot of stuff with a date. You have date add. You can choose what to add to this interval. Let's say we have date add of year 1, and we have a specific date. We have a today's date. And you to understand, we want to add 1 year to this date. If we specify 1 day, it will add 1 day and it will output you 1 day. In this case, we added 1 year. The same we can do with date difference. Here we have the today's day and the same date, but the different year. So we want to know what is the difference between these two dates in years, and we got the -2. If we want to know about how many days is the difference between, okay, we have to add 731 days to this date in order to get today's date. We have to subtract 2 years from this date to get this date. Date from parts, it's you can build, let's say, your date with the following values. You have to specify the year, the month, and the day, and you get this result. The date name returns a character string represents by the date part. So the date name gives you what you want from this date. You want the year, okay, it gives you 2022. But if you want the day, it will give you 13. If you want the month, it will give you 2, and so on. Pretty simple, pretty intuitive. Date part returns an integer. Okay, date name returns your character string, but here you got an integer. So date integer gives you this output. The day. So the day returns an integer representing the day part of the specific date. If you would mention a date in quotation marks, you got the day 13. Sys date time returns the date and time of a matching of a machine the SQL server is running on. So when I run this query, it was 21st of January. So this is, you can check your machine in the same way. Select sys date time. Also, you can do it with sustained date time offset. So remember, the offset is the difference from the UTC. CSUTC date time returns the date and time of the machine the SQL server is running on as UTC. Yes, here, as you can see, it's we are in the time zone with plus 2 hours, and if we do UTC date time, we got these 2 hours in minus. Let's say like here is 17 o'clock, and here is 15 o'clock. Year, the same as the date, we can subtract an integer representation of this date, and the month. The month, like pretty intuitive. If you want the month of date, you use this function. Select get date returns the date and time of a machine the SQL server is running on. And get UTC date, the same how I mentioned. And the last slide is date, returns the int, returns 1 if valid date time, and not if in case it's not a valid date time, it returns you 0. So it is this, no, it's not a string, it's actually a date, but in quotation marks, yes, it's a date, but hello, it's not a date, and it returns you 0. So that's it for our workshop. We have 7 more minutes, but nice that I managed to present all the information. I hope you liked. I hope it was useful. Maybe, you know, for those who are familiar with SQL, you knew this stuff. Maybe it was something new. I really hope you got something from today's workshop. So I think that's it. We will see each other in 37 minutes at the last workshop with me, and the last workshop with from this Sunday, and you'll be free today to do your stuffs, to enjoy the weekend. If there are no questions, I think that's it.